we're going to look at second derivatives, and additionally we're going to look at derivatives that are higher than a second derivative. Okay, so for most cases, a derivative that we've solved for can be differentiated again, and this is an important aspect because it's going to help us in our cubic function graphs. Okay, and all that's happening is you're going to apply the derivative rules a second or a third or a fourth time. So if I take this example, I've got the function of x, which is equal to x cubed plus 5x squared minus 11x plus 4. If I find the first derivative, that's what we call this, the first, because it's one little dash, of that, I end up getting 3x squared plus 10x minus 11. But I can apply a second derivative to that. I can do a second derivative, and I can then get 2 times 3 is 6x plus 10. And if I want, I can apply a third derivative to this, and I end up getting 6. I can even apply a fourth derivative to this, which ends up giving me 0 because of my rules. Okay, so when I'm applying different derivatives, all I do is I use the same rule, I apply it over and over again. Now, when we're looking at cubic functions, we're going to pay close attention to second derivatives. That's an important aspect. And what I want you to also understand is that obviously our notation changes a little bit. So if I'm writing my derivative of y, the function y with respect to x, if I'm going to do a second derivative, if I want to move on to the second derivative, I'm going to write the second derivative of, not x at the top, my function y with respect to x. So there I put this 2 on. If I want to do my third derivative, I can go d3y over dx3. And so on. I can go do my 10th millionth derivative. Mostly we don't ever get to that point, but I can do my fourth derivative by writing it like that. Not really difficult. It is something that you do need to pay attention to and know for now. Our next session, we're going to move on to a new chapter, and we're going to talk about graphs of cubic functions and optimization and rates of change.